Especially due to cryptocurrencies such as Bitcoin, blockchain technology has garnered more and more attention in recent years. It is considered by some to be one of the most revolutionary inventions in recent human history, alongside the emergence of the internet and the development of artificial intelligence. This is because it not only serves as an essential foundation for cryptocurrencies but can also lead to impactful changes in many other areas, from supply chain management to healthcare, by making complex transaction processes more efficient and secure, and thus advancing interpersonal communication and interaction worldwide. In this video, we'll take a closer look at blockchain technology and explore how it can be successfully put into practice. To clarify all of this, I will address the following questions in this video. First, what are blockchains? How do they work? What types of blockchains exist? Why are smart contracts a crucial extension? And where and how can blockchains be applied? Let's first clarify what blockchains are. A blockchain is a decentralized database that stores transaction in interconnected blocks. The transaction data stored in the blockchain is immutable, secure, and also transparent, which means accessible to everyone through cryptographic mechanisms. So in summary, a blockchain exhibits four key characteristics: decentralization, transparency, immutability, and security. To understand how these characteristics can be fulfilled by blockchains, we will now take a closer look at how they work. To do this, let's first divide the term into its two parts, block and chains. A block is a digital storage medium in which transactions and all associated transaction data are stored. These can be typical exchange and financial transactions, but also logistic transactions, or transactions relating to data management, such as the execution of registrations. The transaction data can be seen by everyone in the network and can therefore be tracked by any user. This enables transparency throughout the entire system. Because the capacity of a block is limited, and storing all information in one block apart from that would not allow decentralization, but on the contrary, would quickly lead to central control. The transactions are stored in chronological order in several blocks that are concatenated with each other. For the chaining, a cryptographic conversion process, also known as hashing, is used. Hashing basically creates an output or a hash from an input with the help of a hash function. Let's now apply this to the blockchain. The blockchain always starts with an origin block, which is referred to as the genesis block. In most cases, this block only serves as a starting point for the blockchain and is given a certain hash number. In addition to the transaction data, the hash serves as an input for the next block, for which a new hash is generated with the help of a hash algorithm that includes a specific hash function. Because the hash of the previous block is always included in the calculation for the generation of the hash for the new block, all blocks are aligned with each other. Therefore, each block always has only one specific predecessor and successor block. This makes the chain immutable and thus tamper-proof, since a subsequent attempt to change a block would destroy the entire subsequent blockchain and thus all the information it contains. Of course, as new transactions are made daily, the blockchain must be scalable so that newly received transactions can be integrated into new blocks that are added to the blockchain. In many cases, this is done through mining. Miners are responsible for creating new blocks and connecting them to the chain, for which they always receive a reward in the form of transaction fees or additional assets. To do this, they pick specific transactions from a transaction pool containing all incoming transactions which they first validate and verify before they can be integrated into a new block. In order to be able to link the block to the chain afterwards, a consensus mechanism, which means agreement algorithm, is decided, which determines how new blocks are added to the chain and for which hashing again plays an important role. The most common consensus mechanism is proof of work. As the name suggests, a lot of work, which means time and energy, is needed to solve cryptographic functions. From a mathematical point of view, these functions are based on randomness. This is because an additional special number, also known as a nonce, is often included as an input in proof of work. A number must be inserted randomly for the nonce until a certain sequence of numbers is generated in the hash of the new block, which can then be linked to the previous block. However, since in most cases, millions of numbers must be inserted for the nonce before the right one is found, high-performance computers specially adapted to it are used for mining nowadays. Besides proof of work, there are many other consensus mechanisms. One of the most well-known of them is proof of stake, which, unlike proof of work, is not based on solving complex mathematical problems but on the amount of the stake of certain assets. Therefore, proof of stake clearly differs from traditional mining. This is because in proof of stake, in addition to the transaction data and the hash of the previous block, the stake of assets is also calculated as input for an algorithm which determines a validator who creates a new block and adds it to the chain. The following is important for the algorithm. The higher the stake of assets, the higher the chance of being selected as a validator and thus of creating a new block of the blockchain. After understanding how blockchains work, we can now look at the different types of blockchains. The most common classification is a distinction between public and private blockchains. Public blockchains are accessible to anyone and can be accessed at any time. Therefore, they provide transparency, security through decentralization, and more anonymity. New users can often actively participate in public blockchains, which is why they are also often considered non-permission blockchains. But this not always has to be the case, because there are also permission blockchains, whose access is limited to certain participants. However, due to their restricted participation, they are more likely to be categorized as private blockchains in most cases. This is because private blockchains are not accessible to everyone, but only to certain user groups. As a result, they provide more privacy and better security through regulation. There are also fewer scaling issues, so transactions can be executed faster. However, public and private blockchains also come with significant disadvantages, which can be indirectly seen in the advantages of the other type. That is why there are also hybrid approaches to benefit from the advantages of both types, such as adding sidechains. This involves attacking subchains to the main blockchain in order to outsource certain transactions and create subnetworks for special use cases. Speaking of specific use cases for transactions, we must discuss smart contracts. Smart contracts are digital, self-executing contracts that are based on the blockchain and therefore do not rely on intermediaries. They are executed automatically when predefined conditions are fulfilled. We will now clarify how exactly smart contracts work. First, a programming code must be created for the smart contract, which defines all the conditions for executing the actions contained in the code. This code is then usually included in a transaction and integrated into the blockchain with the help of the associated block and its transaction data. In the future, the address of the block can always be used to refer to the smart contract code. If a transaction that is received and fulfills the conditions contained in the code is now integrated into a new block that is added to the blockchain, the actions contained in the code will be executed automatically. We will clarify how this can look in practice in a moment. The block, and thus also the transaction execution contained therein by the smart contract, now remain visible forever and can be viewed and tracked by any user. This reinforces the immutability and transparency in the blockchain and thus ensures even more equality and security among all its users. It also allows transactions to be processed much faster. All of this makes smart contracts an enormously beneficial extension to the blockchain. If we now transfer this knowledge into practice, it becomes clear that blockchains and smart contracts can be used in a very wide range of areas and sectors for data management and data tracking, if their scalability can be further increased and transaction times reduced. But since the statement would be too superficial to conclude this video, we will now take a closer look at a realistic present-day use case for blockchains and smart contracts. The use case we are looking at is in the healthcare sector, where they, for example, can be used very effectively for drug distribution chains. Let's now take a closer look at how such a drug distribution process with the help of blockchains and smart contracts can look like. Before a manufactured drug can enter the distribution chain, it must first be carefully checked for quality. All related information, which includes the date of manufacture, manufacturing process, and its chemical composition, can be integrated into a transaction and a new block that is added to the blockchain. A smart contract code with predefined quality checking parameters can automate the process of quality assurance. In this case, of course, it is very important that the criteria for successful verification and confirmation of the transaction are defined very precisely and checked regularly by humans. If all the parameters are fulfilled and the manufacturer sells the drug to a wholesale company, this transaction can also be executed with the help of a smart contract, in which, among other things, the payment terms, product quantity, and price are determined. The subsequent delivery of the drug to the wholesale company can also be commissioned automatically. This combination of integrating information about the individual distribution steps through transactions and blocks and the automated confirmation and execution of subsequent transactions using smart contracts can now be used for the rest of the distribution process. Through hashing, a chronological and immutable transaction history is created, because here again, the transaction data can always be included as an input alongside the hash of the previous block to calculate the hash of the new block and add the block to the chain. So after the smart contract has automatically commissioned the shipment, information about transport and storage by the wholesale company are then integrated into new blocks. After the conditions for transport and storage have been successfully checked, which again can be done with the help of smart contract, the drug can finally be sold to a pharmacy and shipped there. As mentioned previously, when smart contracts are used widely for the distribution process, it is very important that the conditions for automated execution are always counter-checked from the human side. Now, when the patient who needs the drug is standing at the checkout in the pharmacy, he can track the whole distribution process in a transparent way with the help of the created blockchain to see if everything went smoothly before he buys the drug. I hope this simple example has shown you the potential blockchains have in practical implementation to make extensive processes not only faster and thus more efficient, but also more secure and transparent. If you are interested in cryptocurrencies and want to understand how blockchains enable a decentralized payment system, then I advise you to also watch my other video on cryptocurrencies and blockchains. If you have any other topic requests, then let me know in the comments. And otherwise, until next time.